Hello, everyone. Thank you for joining us for today's Caringo Tech Tuesday webinar. This session's topic is how object storage makes it easier to access your data from anywhere. I'm John Bell, Senior Consultant at Caringo. Before we get going, let's go over a few operational details. We've loaded some useful resources that you will find in the attachments and links box on the right side of your screen. And note also that there is a question field there. So please feel free to ask questions throughout the webcast, or you can save them for the end during the Q&A section. And if you have some follow-up questions for us, you can also email us at info@caringo.com. Let's go into introductions. I'll kick it off. Just briefly, I am John Bell. I'm a senior consultant here at Caringo. I've been with Caringo for 8 years. And in that time, I've had the opportunity to deploy Caringo Swarm solutions to a wide range of customers worldwide. And our guest expert today is Ryan Meek. He is a Principal Solutions Architect here at Caringo. Ryan, welcome back to Tech Tuesday.
Hey, thanks, John. Very glad to be back. I have had roles at Caringo including development, technical account management, and technical sales, starting all the way back in 2006 with Swarm version 1, beta 1, which was then known at Castor as Castor, and I'm currently the Principal Solutions Architect at Caringo.
Excellent. Thank you, Ryan. Ryan has been with us from day one and is an excellent resource.
Thank you, John.
So just a little bit about Caringo before we dive into things. Caringo was founded in 2005 to change the economics of data storage by enabling software-defined object storage solutions to tackle relentless data growth. Today, Caringo's products are market-hardened at version 11 and are used across many industries, including organizations such as the Department of Defense, the Department of Justice, the National Institute of Health, Argonne National Labs, British Telecom, NEP, Rutherford Appleton Labs, the Brazilian Federal Court System, and hundreds more worldwide. And with that said, Ryan, I'm going to hand it off to you and you can take it away.
Okay, thanks, John. So I'm really excited to take you through, I think, what will be a little bit of a history lesson, but ends up really kind of very topical and very of the moment as we're all sort of dealing with the way the world's been turned upside down, and we're all working from home and accessing content worldwide. So we'll go through location independence, service-oriented architectures, so the way that application data has really evolved and gone forward. And so without further ado, I would say, data access and accessibility is more important than ever. The world is data-driven. More and more organizations are moving to not only remote work models, but remote data models. Content is living at data centers. They're living at data centers in different countries. The demand for content has skyrocketed. So what was once sort of object storage for archive or backup has turned into a very active archive, including new sources of content like social media, and really sort of enabling collaboration between different work sites. It used to be a little bit of a niche or a luxury, and now it's just, it needs to be baked into the architectures and baked into the data access layers that everyone uses. So that kind of takes us back to the beginning. So in the beginning, that just reminds me of the classic Neil Stephenson essay, in the beginning was the command line. But we had, let's see here. So we had file systems, and we had NAS, and we had databases. And they didn't do web scale, and I should qualify that a bit. They didn't do web scale out of the box. So you could put services around them, but they led into essentially requiring that these applications will need to scale horizontally, and that's what Swarm was always ready to do. So we'll just go into service-oriented architectures here. What was really important was services could be discovered dynamically. They could be called from anywhere within a network. And object storage influenced by service-oriented architectures really kind of evolved to where no matter where the applications were when they were started up, they could find their services. They could find those clusters, be it on the local network or by using sort of internet infrastructure. And so these applications could create, read, update, and delete content. It was really re-architecting towards atomic operations, and we incorporated that using eventual consistency. So, you know, these are very large clusters with no central points of failure, but also no single points of locking. So that means, you know, transactions come in, and then time was used as an eventual consistency sort of tiebreaker. Also, kind of the idea of black box application layers. You know, the way Swarm did it was really creating a black box, and this is really in a positive sense of a black box, where the implementations of the operations were hidden from the end users, so they just didn't need to understand that complexity. And not only that, that sort of prevents sort of bad programming habits where someone could be writing to backdoors or writing to areas that weren't sort of the front-end REST implementation. And these services could also incorporate underlying services. So in our case, you know, we tap into Elastic as the sort of web standard best practice metadata indexing tool. Elasticsearch sort of overtook competitors some years ago, and that's been a really bulletproof underlying service for Swarm. Caringo Gateway as well, you know, also consumes other services and offers things like S3. And, you know, underlying services for authentication and authorization, like we'll also get into. You know, these services can all be consumed, they can always be used, and they can interact with the users. And these are all kind of ideas from service-oriented architectures. The way that's moved forward, you know, if you've been sort of paying attention to application programming practices and the way new systems are being developed, this really evolved into what people are calling microservices now. Microservices were really just bringing forward some service-oriented architecture ideas, but now they're used for delivering content at scale. So what's really important there? No single points of failure. Distributed truth, that goes back to, you know, eventual consistency. And then how to monitor distributed services. You know, we've done work specifically here noted with Prometheus to actually take operations and counters across an entire cluster of Swarm just to enable sort of modern DevOps practices where people will be sort of empowered to produce their own dashboards. We have you know, a dashboard that we've put out there in the public specifically for Grafana. And we've made that freely available, and people have actually altered it to meet their own needs. You see that in internet content customers that we have. You also see it in government customers that we have. It's really interesting visiting some of these places where you walk in and the hallways or the knocks are just filled with these sort of dashboards, so that at real time people can at a glance see the status of their services and their response times, and available capacity, any kind of recovery or high availability situations that are going on. It's really at a glance the way very large systems are being monitored and observed, even in the offices. And I would say too, related to that, we've been working on and enabling containerization, which I think we'll say a little bit more about later as well. That'll be sort of coming from in the fall. But the key element here is fitting into containerized architectures with the same sort of reliability and availability of your microservices. So really taking the ideas of service-oriented architectures, honoring the kind of microservices deployment techniques, and then enabling deployment of those services with DevOps dashboards and containerized Swarm. These are all ways that the sort of spirit of the times is reflected in Swarm software.
And Ryan, if you don't mind me interjecting here real quick, to Ryan's point in that second bullet, regarding distributed truth, that is the meat of what we're trying to get out of deploying against this service-oriented architecture approach. That is the capability that lets you basically take data in from anywhere, have it show up in other entities' live queries for data sets that they may be working on, so that at any one point in time, you're always getting the latest updated information that could be coming in from anywhere. It's eventually consistent and distributed to remaining work teams all over the world, and they know that they're always working on the same thing that's as up to date as it can possibly be.
Yeah, absolutely right, John. And in fact, we can get a little even more in the weeds on that, which I think is kind of fun to do in a format like this, because I think everyone benefits from it. So let's say you're working on a giant distributed system and you want to see the latest and greatest updates to any particular files or particular buckets. And Swarm will do that by reliably serving the most up-to-date version of that content. By the same token, the clusters can be configured to keep every version. So if any version is a surprise or comes to be thought of as an inferior version, a previous version can be brought up. And sort of not only that, but an application that is writing with its idea of the previous version can include that version tag in the request. So if that isn't the current version, then maybe the application needs to go back, get the current version, and perhaps edit it before updating. So that's getting into feature sets that are even more important for things like version control systems. So at the same time, it's a distributed system with no single points of failure. It also has hooks for version consistency, fully versioned clusters, and yeah, oh, by the way, these are the same mechanisms in HTTP that are used by sort of forward proxies to see whether they have the current versions of objects and perhaps need to update the current cached version. So yeah, thanks for that note, John. Those are excellent points to bring up here. So yeah, and what we were just speaking about, so worldwide access to content. That's kind of easy to say, and sure, you can route requests from all over the place if you want to, but let's say you have offices in a few locations and data centers in a few locations. The recommendation that we've always made since the beginning is actually naming clusters corresponding roughly to DNS names. This actually gives it a global naming system so that you don't have necessarily conflicting clusters that are all named production. very important when you put them all together. And then that system actually includes disaster recovery inherently because they can be configured as each other's DR site asynchronously and including content from other locations. Locations can be configured to route content specifically to, one or more other locations. So, that's commonly what we would call like a hub and spoke graph, but it can be really an arbitrary graph replicating content in a certain direction. It's probably a good time to preview something we're working on currently for a large streaming system called remote synchronous write. In general, the data protection mechanism between clusters is asynchronous, so that if there's any connectivity issue between the site, you can continue writing to the primary location. But in some cases, like especially if you have different processes to either make content available or perform actions on content, you want that replication to be synchronous, so that actions at multiple sites aren't initiated on content that isn't there yet, if you see what I mean. So in the default setting and in most of the installations in the world, the replication is asynchronous. But we have coming soon remote synchronous writes where the objects will be guaranteed to be in multiple locations before the original call returns. So, we're very excited about that. So, and on top of all of that, so mostly we've been talking about how to access your data, how to guarantee the data is accessible all over the world, how to name clusters. The fact is it's HTTP, so writing, requesting content, reading content, that will route around damage. That will be sort of inherently provided by the right naming system and DNS. But then really authentication and authorization is what you need to guarantee that not everyone can access all of your content. So on the one end, it's enabling everything with the features, and on the other end, it's making sure that only the correct people can access the content. When we were developing these, I actually had a note here, legacy PAM, but pluggable authentication modules in Linux, they may be legacy, but they're probably also the most commonly used. Wouldn't you say, John?
Yeah, I'd say that's the case.
I mean, go ahead.
Well, there's a, I just was noticing there's another bullet here that's kind of implicit, and you touched on it a little bit in the previous slide. So I kind of wanted to bring it to the front burner because it's a good conversation to have. And it's that concept of separation of access from the parties that administer the infrastructure for the storage, the servers and whatnot, versus your content administrators. And in these type of systems, especially in our solution, those entities can be completely separated from each other. You don't have the concept of a storage administrator who's administering the servers also needing to be able to manipulate the data at some kind of escalated privilege, because those mechanisms are completely separated from each other in our solution. And that goes back to the concept of having these end-to-end relationships between storage installations across, geographic distribution. You could have a swarm storage cluster in New York. You could have one in Madrid. You could have another one in Tokyo. You could have one in Sri Lanka somewhere. And all of those storage administrators, they're just constrained to, having access to their individual, stack of equipment, basically, for lack of a better way to describe it. But you could have a content administrator who is able to manipulate content on more than one, or perhaps even all of those clusters, worldwide, and set up the appropriate, policies that would reflect that need. And that goes back to the multi-tenancy, the policies that you can assign, to tenants, to domains, and even down to the bucket level.
Yeah, that's a great point, and I think that's where we really shine, as where we have true multi-tenancy versus, a super user login at each site that can do everything, and then, that where it's not really clear how to assign sub-administrators and subcategories. I mean, our system was sort of designed to enable the concept of authentication and authorization can be federated, and so sub-administrators in different domains can also, have control of their own content appropriately.
Mm-hmm. And we even allow for, in situations where it's necessary, cross-tenant authorization. There are mechanisms in place for that as well, so that, certain subsets of data across multiple tenants can be accessible by the same group of people. Mm-hmm. Mm-hmm. Just as an example.
Which is right, and which is exactly important, so that data doesn't have to be duplicated across different areas just because the authentication system doesn't include it, right?
That's right, yeah.
And I would say the last thing to just note here is, along with being a first-class S3 protocol sort of provider, we also have the ability to layer tokens and secrets, token-secret pairs across those multi-tenant authentications and authorizations. So, it's really kind of a best of breed, and the ability to do both is something that enables quite, all the use cases that we've encountered.
Right. Yes, it's a very comprehensive implementation.
It is. So really, just to go over what we've sort of introduced and covered at varying levels here. The core object protocol is HTTP. So when you add HTTPS, you add the ability to be secure and encrypted. The authentication mechanisms are there. Routes around obstacles are there. The certificate systems are there. So that's really, all about authentication of endpoints, are people who they say they are. It's all leveraged. And then, at the S3 level, which is S3 over HTTP, this is one of the most widely adopted and supported protocols in the world by applications. We're testing and getting certified on new ones every day. So we don't even really know at this point how many applications work with us seamlessly. And, those protocols themselves leverage so many parts of, say, DNS, internet time servers. I mean, these are all massively scalable, massively reliable, highly available global infrastructure that Swarm not only relies on but leverages to provide a worldwide accessible framework for user data. So I hope that's been a useful summary of data access, sort of why it's important, why it's up to the moment. Are there any questions that have come in, John, that we should answer before we move on?
There are none informally. I would just touch on the point that when you're working with a storage solution like Swarm, which is built from the ground up to enable this level of, multi-tenant, multi-user collaboration across wide sets of data. And it's so difficult to do this type of work with traditional storage solutions such as SANs or NAS, because you have to build so many layers. You have to build application layer, web layer, and all the complexities and the dependencies that go with that, just to surface traditionally stored data to groups in this fashion. Whereas something like swarm object storage, it's designed, built from the very beginning to enable that type of work, to enable that type of collaboration and workflows and so on. It just makes your life a lot easier when you find yourself, in this day and age where collaboration of remote teams and work from home teams is key.
Yeah, excellent point. And while you were noting that, we did have a question come in. And the question was, when we say S3, does that mean it only supports AWS, or does it support others as well as Google Cloud or Azure? So that's a great question. What I would do here is I would distinguish between S3, the AWS service, and S3, the data access protocol that has become standard that S3 initiated. So the S3 protocol, you can use that to connect to AWS, but you can also use it to connect to, say, Wasabi, or you can use it to connect to, say, a tape library that has an S3 gateway on the front end. I would also note that to connect to Google Cloud or Azure in a Caringo system, we also have an excellent component called FileFly that can route content to those providers as well. So I think the first part is just distinguish the S3 protocol from S3 as a first-class service, and then if those other clouds are actually important to the workflow, we do have ways we can incorporate those as well.
Excellent. Well, Ryan, I don't see any other questions coming in. So with that said, thank you for presenting today. Great stuff. Really appreciate it. And thank you everyone for joining us today. I'd like to invite you to join us for upcoming events. On June the 4th, we're having episode 6 of our Brews and Bytes webcast, and that will consist of using the CIA promise, not that CIA, the other CIA, to protect data. And we'll be presenting with our partner Zenith for that Brews and Bytes. And on June 23rd, Ryan is going to be joining us again to sit in the host seat, and we'll be doing our Tech Tuesday webinar for cloud seeding with object storage containers. To keep up with Caringo, you can follow us on LinkedIn and Twitter. And if you have additional questions for us or would like to schedule a custom demo, by all means, please email us at info@caringo.com, and we'll be happy to present to you and demo and show anything that you have particular interest in. And with that said, thanks again to everybody. We hope you have a great week, and we look forward to seeing you next time. Bye-bye.